Facility engineer there. My background, I went to Iowa State. I'll say it again. I thought, I could leave Eastern Iowa and not see a tiger hawk, and failed. I saw an Iowa sign today also. So I've been working for General Mills for about 2.5 years. I'm pretty much solely focused on energy projects at this point. So they dedicate me about 100% of the time doing these kinds of projects. Before this, interesting thing about me, I was an expatriate in Trinidad and Tobago doing oil refinery upgrade in the construction industry, so it was nice to get back to Iowa and get back to doing energy. Got a lot of experience in. So General Mills has 47 plants in the United States. Just to talk about our relevance, we are in Iowa there. So we are the largest manufacturing site. We do about 10% of the production of all of the other facilities. We make Big G cereals such as Nut Cheerios, multi-grain, Cocoa Puffs, Kicks. We do fruit snacks like Fruit Roll-Ups, Gushers, shakes, gummy bears, and then we also make frostings and desserts. We have a good portfolio. We used to do baked goods as well. So we compete internally and externally for a business. We compete with Kellogg's and most. We also compete with other cereal plants and things like that to make the product and get the volume to stay here in Iowa. So energy is a big portion of how we stay competitive.
Is it Lucky Charms that smell so good downtown? I know I've been down there, it just smells awesome.
Yeah, we don't make Lucky at our plant, but we make frosted Cheerios, and that is similar, yeah. So we make frosted, it's pretty good there. So we had lots of warehouse storage, idle equipment areas, cold freezer, cold storage areas, mezzanine levels that were highly lit but not very much activity. And a lot of lights were coming to the end of their life, and we wanted to do something new. And we kind of got hooked up with Iowa Economic Development and found that there would be a grant way to try LED lights. So we went and formulated a project to do that. So, we had a variety of fixtures that we replaced. We had some T8 high bays that were pretty efficient themselves, but they had their drawbacks which I can go through. We had 301 of those. We had 26 in the metal halide, big 400 watt users, and we had about 8 sodium lights that we were trying to phase out that are 300 watt users. So between that mix, we were looking at trying to find one fixture that could do it all everywhere and standardized. And originally we were just looking at the one more replacement, and we just wanted to test how the LEDs work and what kind of issues they have. So it was a good time for all of us. So if you look at our facility, internally this is labeled with all the cool areas and stuff for the external presentation, but the 2 green areas are the big areas of our plant that we did all the lighting retrofit from. So that's kind of gives you a feel for our layout and where they were at. And so what we selected was a Phillips A-Bright high bay fixture. They're quite a bit smaller than you're used to seeing. The T8s we had before were the 6 lamp T8s. They had the 2 or 3 valves in them depending on the configuration. And so these were quite a bit smaller, but they also use a lot less input watts. You see they're 144 watts, and their light output was still pretty good at 11,000 lumens, and it has a pretty good efficiency. So what was unique about these, we found an occupancy controller that we can do full output, and then when after 2 weeks set it's variable from 30 seconds up to 15 minutes. You can go down to a dim operation setting, which I was told is about 5% power output. And then because we have an emergency circuit, we can go all the way off in areas as well. So this kind of helped us ease into the occupancy control in an area without being on and off all the time. With it being dim but still light there, it made everyone feel more comfortable and safer. So it was a nice option that we found with the Day-Bright technology. So first I'll kind of walk through the savings. So on its face, the energy savings really wasn't that high at $20,000 a year, but working with Alliant, they did a really, really detailed study, and we kind of blended rate structure. And so if you do the math and say we saved 455,000 kilowatt hours and divide that by 8760, you should get 56 kilowatts of demand reduction. But because we couldn't guarantee with the occupancy sensors that they'd be on all the time, we actually did a really good job of looking at the real impact and saying, so pretty much this 20,000 was a guaranteed out of the gate. You were going to for sure hit this savings on energy. We also looked at how much we were spending to repair the old fixtures. They each had about a 2-year life before, or a little bit over 2.2. And these new lights have a rating for 100,000 hours. Now we haven't been able to prove that yet because we haven't had them that long, but so far we haven't had to replace one. So we were using not even our maintenance department, but our contractors to do the repairs. And every time we sent someone out, it was $165. So after looking at all the repairs of all the lights, we determined that we probably spend about $26,000 to do all these lights in all these areas, which is quite expensive, and something we were also going to look to internalize if we didn't do this project. So to help us do this project, we partnered up with Alliant Economic Development. They brought us to the attention of the American Recovery and Reinvestment Act. What this allowed us to do is to get a grant for half of the project cost. There were some requirements. It had to be a green technology. So we looked at doing, wind and solar and a new renewable technology like that. But at the time we found out the award was available to us, we only had about 4 months to turn it around. So from the day we thought of it to the day it was done was about 4 months. And it really speaks to the speed at which all the parties, Shelley in their office, the city of Cedar Rapids, and then all of our contractors really got this project approved, funded, and completed. And so for this Reinvestment Act, you have to do the Buy American Act. That's the reason we chose the Phillips, Dave Wright, is they were all made in down in Texas, a plant down in Texas. And they also have the capacity to make these lights in this quick turnaround. Our contractors had to follow the Davis-Bacon Act that sets the wages that you have to pay electricians and trade workers, and they already met these requirements, so they did fast for us to keep them on board. And then it had to pay back within the useful life of the lamp in 10 years. It has to pay back within 10 years for the grant part. So this project was about, I have a summary side, it was a $309,000 project. We had $155,000 of that back from the American Recovery and Reinvestment Act. And then also we were able to partner with Alliant Energy, our utility provider, and they have a nice custom rebate program, which you might hear a little about. You've heard a little about already today. So you get incentives equal to 150% of the energy savings, and that was calculated by them, third party. Not on what they say, but they hire Michael's Energy to do some good study. And so they're a minimum 2-year payback after all the meat and potatoes comes down. And so for this project, again, we saved 455,000 kilowatt hours at 34 kilowatts of peak demand. So the custom rebate was a little over $30,000. So 1.5 times the 20,000 they calculated. And so they have a really good website with all their custom rebates. There's lots of other upgrades you can do. I will also say that you can get rebates for your homes for doing water heaters and stuff like that too. So it's cool. It's a website to check out. Yeah, there you go. There you go. So then, the overall results. And so there's a picture of one of the pictures. Is that we did 326 of these fixtures. It cost, like I said, $309,000 in cost. We saw I counted as $233,000 in cost savings. 185,000 of that was the one-time grant, 155 in the Alliant of 30, the 46 in annual energy and maintenance savings. And then we can't calculate it towards our cost savings, but we also did receive a PPAC tax credit of $144,000 on top of this. That goes to the corporation, not to the plant, so we can see that. Kind of success of these lights is we found that it was better than a one-to-one replacement because of the spread and the brightness we found. So we were actually able, also, why I think that 20,000 is conservative, we were able to do more scope than we thought. We extended it into some of our process areas, aisleways, and areas like that with the same 326. So we took out 326 and we probably replaced 350, 360 lights with the spread. And we found overall that the test was successful in the warehouse areas as we hoped. So our lessons learned, as I've said, is good energy maintenance savings. It was good community outreach, partnership with utilities. It's good, quick turnaround. It was nice to standardize a lighting fixture and not have these tubes hanging around and different ballasts and shelves of all this. That's kind of intangible. You don't count on. Area, like I said, was a lot brighter. People seem to like it more. The transition from on to off wasn't so bad. The dim modes, that worked really well. And then lighting in general, when you do projects, they may not be your biggest hitter for your energy budgets, but they're very visual and aware. So because of this, they saw we wanted to do lighting projects, and we were excited about energy savings. We would get suggestions from operators on the floor, like, oh, have you looked at this yet? Have you looked at that yet? And we really didn't see that much interaction until after we did a project at the scale with this visual impact. Some challenges is with the adjustment to the occupancy sensor, it wasn't that it does dawn off, it's just the duration and getting that set up for each little area. Homing in like 2.5 minutes because we had so many variety options. It's a little trial and error to find that time, where it's just long enough for them to get in and get out, but not too long, you're wasting energy, not doing too quick, where they're kind of left in the state. We did find that LED lights can affect scanners and your HEVs, and a lot of your plant use HEVs. If they incidentally hit one of your reflectors, they can send false signals. We found in a few areas that they did. So all we had to do was turn the reflector shield slightly out of the light, and it didn't all the powers away. So it really wasn't a big challenge at all. It took us maybe a day to fix, but it was something that we had to be aware of. And then now, some challenge would be the new maintenance skills. We haven't had to work on a light yet. We trained our maintenance department back when we did it, but they haven't seen it yet. So I'm curious to see if I get any calls when one of these does fail. Hopefully I'll be gone by the time it does fail. And then, there'll be some learning there. It's a little micro board and two new panels instead of tubes and the ballast that you're used to. So it's a little different technology. At this point, yeah, is there any questions about the product?
Yeah, the LED lights that we've seen have quite a different color. It's a lot more towards the white or blue spectrum. Did your employees complain about that? Have any problem with it?
The color really was an issue. The TAs that already there were pretty white light as well. The only thing that did took a little adjustment, and it was with positioning, is that when you look right at LED, it is bright in the vents.
Yeah.
So, it was just about getting them a little higher in the roofs structure so that they're looking at the barcode, they're not staring right into the light. But if you do planning when you're installing, you can usually work around it. But we didn't have much complaints about the color. In fact, a lot of times they really liked the change. It looked fresher, brighter, cleaner in the area than before. So.
Did you use the same foot candles or lumens?
Yes. So we were before we went around measured with the light here, and we were about 15-foot candles. Average to go under as well. So now we ended up probably about 17, 18-foot candles.
Put almost the same number of lights.
And put less lights back. Yeah, that's just and then so the Philips Rebate, they do have 4 configurations: highway, low, medium, and wide. So you can really dial in that spread with those technologies. So I'm sure not to plug them. I mean, any manufacturer probably can work with you on the light spread too. And so, but it's a lot cheaper a lot of times to do a one-to-one because the conduits and cables are already there, and that's kind of our cost down.
Light of the light, did you factor in the, right now, if we have metal halide, and when the bulb burns out, you go up and you replace the bulb. But some of the fixtures that we've looked at with the LED, you don't replace the bulb, you replace the fixture. And that's really nice that you have to do it, you get $100,000, $80,000, $100,000, but when it's done, it's done. So do these have replaceable LEDs, or do you replace the whole fixture?
Yeah, the board, so that there's like the 3 pieces. I don't know, have a really good picture. I'll try to go back. So kind of on this drawing, these 2 inserts with the actual diodes on are replaceable, and then internally the board that kind of powers the drivers are replaceable as well. So there's 3 sections. So if you have something go out, you can determine the problem, and only have to order the replacement part instead of the whole fixture.
Did you factor in the cost? Because I assume the components are quite a bit more expensive.
So we said that, 100,000 hours is about 11-year life. We can only take 10 years of cost savings on a project to make it pay back ROI. So we just assumed let's match the spreaded cost of doing the older 18,000 life up to a replacement of 1. So we really didn't have to factor in on the project the maintenance cost of that because we scaled everything with their life, saying because we're only going to claim up until when we have to replace these. That's kind of how we went about it.
Okay.
Because we're not certain, I don't think very many people have LEDs at places, so manufacturer claims we aren't sure if we're going to make it in 10 years. There's not a lot of data on that. They all tell you they do, so,
we'll find out.
So for that risk, we kind of, the 165, we didn't say when we said a fixture would fail, Yeah, but we modeled it down to 4-bulb, 1 ballast fixture for the cost, instead of a, 6-bulb, 2 or 3 ballast fixture to try to lower the claim on the maintenance savings more than it really was. So we said just because of a bulb or ballast comes on the light, we probably didn't take care of that every time. We'd probably say the whole fixture goes out, so we kind of try to scale that back to that expectation as well. Try to be more realistic.
I would add to that, I think when we're using like useful life for a fluorescent system, we usually estimate 11 years. That's based on the DEER database based out of California. So you can think about, eventually your fluorescent light fixtures are going to be to a state where you don't want to keep replacing lamps. You want to get rid of them and get something new. And that's usually around, some people are going to go a lot longer than that, but the kind of accepted useful life for a fluorescent system is 11 years. If you're burning 100,000 hours year-round, that's going to be also 11 years. So that fixture cost is kind of a wash if you, theoretically, if you look at it that way. Also, if you're dimming LED fixtures, there's less heat, and those LED fixtures should last a little longer. And some manufacturers will actually put a number to that. So underdriving those LED lamps in their dim state extends the life, and you should get a little more than 100,000 hours. Some people rate the fixtures up to like 150,000, 150,000 hours for a dim state. So,
And we use the higher L70 light at two temperatures, 25C and 45C. We use the shorter of the two, assuming that the warehouse itself, the ceiling is going to be hot. So
if you're putting them in refrigerated spaces, like you said you had, then that would extend the life even longer.
yeah,
That temperature, it's all about temperature and LED.
we didn't take the dimming out. We just said they were going to run wide out for 10 years straight. That was what we used. We didn't take into account the dimming and turning off periods, which will extend the life of the LEDs. And that was occupancy sensors did get a lot of our savings, but with the current fixture technology we had in, the ballast couldn't handle. We were trying it, and we were burning out ballast because we didn't have the right ones in. So we were going to have to make an investment on ballast either way.
We've seen similar problems.
Yeah. So that kind of gave us the jump to the LEDs in this case. But so far we're happy. I think the fixture prices are kind of high, so you can look around and see who's most competitive for you.
So does General Mills have a lighting standard?
We're working.
Is this now part of your lighting standard in other General Mills facilities?
We're working towards that. We're having 2 other plants, one in West Chicago and one in Buffalo. That's our own lighting solution now, and we're going to do a couple-year trial based on perception and then say, this is what we're going to go for in the future. But this is only one data point. We don't want to make decisions just on this. But we're getting to that, yeah. We're trying to get it standard across the company. And this is a warehouse area. We also are trying to look at a process area. And that's why it was less risky in the warehouse area to do the LEDs because of different color, different light. We didn't want to affect people's workflow.
Yeah, I know, so at Deere, that's been, so we have a corporate lighting standard, and LED technology for like our process spaces hasn't been, it isn't approved yet. Within our corporate lighting standard, we use it for parking lots or dock lights or emergency exits, things like that, but in the process space, there is that concern about, a fork truck driver looking up and looking down and having spots in their eyes when they're driving or things like that. But so we've been doing pilots, like every other year we do LED pilots because the technology is just changing.
Yeah. So think of us as a really large pilot.
Yeah, very much pilot. So I was interested if you did have it in process space but globally,
We do have a LED fixture for process spaces that's washed down, and we've had good success with that as well. They're like more like replace a 2-volt fixture usually, and we've had good success with those too, but we probably only have 15 of those instead of 320.
What's your roof height there?
I think, it's probably around 30 feet, 30 feet, yeah.